concentration of HCl may be determined. It's just a normal simple acid-base titration. Okay? Which means you will need to decide what you want to put in your burette, what you want to put in your pipette, what are the capacities of the burette pipette you're going to use, what is the indicator that you're going to use for this procedure. This is very, very standard. Okay? Alright? Now, you have two different concentrations, one for NaOH, one for HCl. NaOH, you know for sure, is 1.00 mole per dm³. HCl is approximately 3 moles per dm³. Okay, do you think you need to do a dilution? Will anybody do a dilution? Maybe some of you may want to do a dilution. But I'm trying to say that in this case, because the ratio is about 1:3 for concentration, and both are monoprotic acids and bases, you don't need to do dilution. You can do a straight titration. But you must choose your apparatus very carefully. Now, I would choose to use a 10.0 cm³ pipette. You may wonder, do we have this apparatus in the lab? Yes, we do. A 10.0 cm³ pipette. Use 10.0 cm³ pipette to pipette out HCl. Okay? If you only pipette out 10.0 cm³ of HCl into a 250 cm³ conical flask, when you do an acid-base titration with NaOH, what would be your expected titer value? Approximately 30 cm³, and that is perfectly fine because your expected titer range is between 30 to 35 cm³, sorry, 20 to 35, so this falls perfectly within the range. So you pipette 10 cm³ into a 250 cm³ conical flask. The volumes must be stated. After that, you add in your indicator solution. You can choose to use phenolphthalein, 1 to 2 drops. Methyl orange also can, up to you. Fill a 50 cm³ burette with 1.00 mole per dm sodium hydroxide. Titrate the HCl in a conical flask and observe the endpoint when the color changes from colorless to pale pink, adding dropwise near the endpoint. Okay? Alright, there's no need to copy, come. You need to copy. If you want, I can upload this on LMS. Okay? Repeat titration until you get consistent titer values. Okay? Consistent titer values that are within plus minus 0.10 cm³. Okay? Alright? How would you calculate the accurate concentration of HCl? Just use the equation that we have learned. Volume V1 of your NaOH that you use over 1000 times 1.00 will be equal to the amount of HCl. So the concentration of HCl is equal to the amount, okay, divided by 10.0 over 1000, and the units will be terms of mole per dm³. Okay, so this one I'm very sure that you will know. Okay, and in 2015, this didn't pose any problems to the candidates at all. Okay, this was very straightforward for planning. Okay, the tricky bit is the next part, which requires you to look at it from an equilibrium constant perspective. Okay, can I move on to the next bit? Can I? Okay. An outline of how results will be obtained for two different initial reaction mixtures. Okay, you are only given 10 grams of methanol and 10 grams of propanoic acid. You will need to add in the catalyst, which is your HCl. Okay, of which the accurate concentration you have just determined from the previous bullet point. So how can you prepare two different initial mixtures? For these two initial mixtures, you must have different ratios of propanoic acid and methanol. Okay? Alright, and there is a limit to how much of each you can add in because you're only given 10 grams. You cannot have it that one initial mixture you use 9 grams of methanol, and in the second reaction mixture you use 8 grams of methanol. Because 8 plus 9 is 17, you only have 10 grams. Okay? So this part, how to prepare two different reaction mixtures. Very simple, all you need to do is just make sure that you weigh out accurately a certain mass of propanoic acid. Okay? I choose 6.0 grams of propanoic acid. You add it to a clean and dry 100 cm3 conical flask. Okay? I weigh accurately about 5.0 grams of methanol in a weighing bottle, transfer to the same conical flask. I will then re-weigh the weighing bottle to determine the actual mass of methanol used. Okay? Alright, why do I do that for step 2, the re-weighing bit, but I don't do that for step 1? Because for step 1 I could use a tare function, right? But for step 2 you can't use a tare function. Okay? Then in step 3, using a 10.0 cm3 pipette, I will pipette 10.0 cm3 of HCl into the conical flask. Okay? And the next bit, you will need to use information that is given in the question. Stopper the conical flask with a rubber bar so that you get a sealed container. Swirl the conical flask to mix the contents and leave it to stand for 1 week. Okay? Because the question says it will take 1 week to reach equilibrium. Okay? So that's for the first reaction mixture. Now for your second reaction mixture, you need to ensure that you use a different ratio of propanoic acid and methanol. Okay? So just make sure that you use a different mass of either or both of the two reactants. So for my reaction mixture 2, I repeat the whole thing. So I don't need to repeat all the steps. I repeat the experiment above, but I will change propanoic acid from 6.0 grams to 4.0 grams. So I ensure that I have a different ratio. All other quantities remain the same. Okay? Okay? Alright, so I was also reading through the answers that you have in your topical TYS. So from the answers from your topical TYS, they say that they wouldn't use a mass of propanoic acid that's more than 2.39 grams. Because the consideration is that the amount of propanoic acid will cause the titer value to exceed 50.00 cm3, which might be true. Okay? Right, so as long as your justification is chemically sound, I think it is okay. Right? Likewise, I think if I have this here, I'm pretty confident that I'm getting full marks for this. Okay. Okay? Alright, now, the tricky part is this part. Okay? Brief but specific details of the results would then be used to determine the amounts in moles of all the components in one of your reaction mixtures. Okay? Alright, as well as the component of propanoic acid in equilibrium mixture, as well as all the other components in the equilibrium mixture. This part is going to be tricky. Okay, so can I give you about 10 minutes to work out roughly how do you think you can determine all the components amounts in the initial reaction mixture? Okay, based on these quantities that we have added in. Alright, so it's easier for us to determine that. Okay? As well as Point number 2, the amount of propanoic acid. Point number 3, the amount of all the other components in the equilibrium mixture. Okay? Right? If you can work those out, I think you have grasped the key concepts in chemical equilibrium. Okay? Alright, 10 minutes to do that. If there's any questions, just raise your hands.